Alright, y'all, you have the inequality test for absolute values and linear inequalities coming up. Okay, so we're going to go over some of the problems, not all of them. The answer key is posted for all the other problems. I just picked a couple that I think that will make the biggest impact to help you out. So we're going to go through these problems. Okay, so number one, the nice thing is this is already solved for you. But anytime you have the inequality brackets or the inequality bars, you have to separate. So the first time is exact. The second time you flip your symbol and the number is opposite. Okay? So knowing that, I'm done because there's no more work needed than that. And I'm going to go ahead and put it on my graph. Okay, so one thing I do need to realize, this is a greater symbol, remember, or, so we have greater, which is this symbol, and then we have less than, I'll write a capital, which is this symbol and this symbol, okay? So this is an OR situation, which means it only needs to satisfy one of the inequalities to be a solution. So we have -8 is smaller, 8 is bigger. So it says x is greater than 8. So greater, so another thing is when it's equal to, you use square brackets. When it's not equal to, it's just less than or greater than, you use parentheses. Okay? And if it's an equal sign, you use your fancy brackets, your braces. Okay? Okay, so knowing that, this is OR, and I'm going to use a parentheses. Okay, so it's x is greater than 8, so greater goes to the right. Okay, x is less goes to the left. Okay, so knowing that, I go from -infinity to -8, and then 8 to positive infinity, because I only have to satisfy one or the other. So -8 infinity to -8. Or, use your union symbol, 8 to infinity. Okay. So let's look at number 2. It's very, very similar. Okay. This says absolute value of x is less than, so it's and 8. Okay, so knowing that, I'm still going to separate. X is less than 8. First time is exact. Second time is a flipped symbol and opposite. So, throwing markers. I have -8 and 8. Okay, it says, so again I'm using parentheses because there's not equal to, so x is less than 8. So less than is to the left. Okay, x is greater than 8, -8, goes to the right. So again, technically these lines keep going, but the only place you find your solution when it's and is where it's double shaded. So everything that's in my solution is between those two parentheses. So -8, 8 is my interval notation. Okay, so let's look at number 4. So this one looks confusing because there's just a lot, but don't let it throw you off. So I have 3x plus 4 is less than or equal to -20, or -5x plus 6 is less than -19. So I'm going to solve these one at a time. There's no absolute value bars, so there's no separating and doing the opposite. You only do that when there's the absolute value bars. Okay, so this doesn't have that, so we don't have to worry about it. So we're just going to work on getting x by itself. So I'm going to subtract 4 from both sides, and I get 3x is less than or equal to -24. Divide by 3, divide by 3. X is less than or equal to -24 divided by 3, which is -8. Okay, same concept, -6 minus 6 gives me -5x is less than, what, -25? Okay, now I'm dividing by -5, and what's the rule when we divide by a negative? We have to flip our symbol. So we get x is greater than +5, because 2 negatives makes a positive. So we're going to bring over our number line. We're going to put the smaller number than the bigger number. Okay, this is an equal to, so I'm going to use the square bracket. So x is less than or equal to -8, so less goes to the left. Okay. Then I have x is greater than 5, so greater is a parentheses, greater goes to the right. So this is an OR problem, so this is okay. So I go from -infinity to -8 with a bracket. Remember, infinity always has a parentheses, or, parentheses, 5, infinity, parentheses. Okay. So let's look at this one. This one kind of throws y'all off sometimes because you have two symbols and it's one big inequality. I like to draw my lines to remind me that there are 3 pieces to this inequality. Okay, how do I get rid of this? Well, our goal is to solve the middle for x. So first thing I need to do is subtract 5 from both sides, or all the sides. This cancels, and I get 10 minus 5 is 5. It's greater than or equal to 5x is greater than -15. So divide by 5, divide by 5, divide by 5. This cancels and I get 1 is greater than or equal to x is greater than -3. So do my number line. I have -3 and I have 1. So remember, cover up one side, only look at it one piece of inequality, and remember you read letter to number. So x is less than or equal to 1. So if it's less than or equal to, it goes this way. Now one thing I want you to realize is that, remember, in these it's always an and, okay, because it's all put together, so it has to satisfy everything at once, so it's and. Okay, x, now cover this side, and it's x is greater than -3, so parentheses to go this way. Now remember, it's and, so technically, yes, the lines keep going, but we're only looking where it's double shaded, which is in the middle. So there's your solution. Okay. So let's look now at number 11. Okay, so this is an absolute value, which we know means that we're going to separate and do the opposite. Okay, so what I want you to realize on this one is that my absolute value bars are already alone, so I may go ahead and separate. Remember, the first time is exact. The second time you flip your symbol and it's opposite. So I'm going to solve. I'm going to get rid of my number first, keep my x alone. So if you need to draw your lines, because I know y'all get thrown off with the symbols. Okay, and I get -7x is less than 1. Okay, divide both sides by -7. Well, when I divide by a negative, I have to flip my symbol. So I get -1/7. Okay, -3, -3. I get -7x is greater than -7. Divide by -7, divide by -7. Remember, when you divide by a negative, flip your symbol. 2 negatives makes a positive, so I get a +1. So I get -1/7 is smaller than 1. So if x is greater than -1/7, well, first off, this is a less than, so this is an and situation. So if x is greater, that's a parentheses, and it's going to go to the right. And if x is less than 1, that's going to go to the left. Again, it's where they're double shaded, so we get -1/7, 1. With parentheses, because there's no equal to under our symbols. Alright, let's look at number 13. So this one is not ready to separate and solve because we have to get our inequality bars alone first. So we need to get rid of whatever's on this side that's not inside those bars. Therefore, I need to get rid of this minus 3. So we're going to add 3 to both sides. And I get absolute value of 7x minus 7 is greater than negative 2. Now freeze. Anytime you have a negative, you stop because you don't have to keep going. So I want you to realize anything inside of absolute value bars is going to be positive. It's going to be a positive number. I can plug a negative number in there, but remember, absolute value bars is your distance from 0, and no matter what, that's going to be a positive number. Okay? So, positive numbers are always greater than a negative 2, or any negative number. So therefore, this is true, which means it's all real numbers. Okay? Now, if it was a positive number is less than negative 2, that's false. That would be no solution. And if you see an equal sign with a negative, if this was absolute value of 7x minus 7 equals negative 2, it would be no solution. Okay? Equal signs with a negative are always no solution. Let's look at number 14. Again, what's inside my absolute value bars is not alone. On the left side of that inequality symbol, I'm going to make it darker. Okay, so I need to get rid of it. Now, this is multiplying, and this is adding, and I cannot put this stuff inside because it's not the same. So I'm going to subtract 5 from both sides, and I get negative 3. Absolute value of x plus 2 is less than negative 9. Divide by negative 3, divide by negative 3. Well, I divided by a negative, so I'm going to flip my symbol. Absolute value of x plus 2 is greater than positive 3. 2 negatives makes a positive. Now I may separate and solve. So x the first time is exact. Second time I flip my symbol and do the opposite. So I'm going to subtract 2. I get x is greater than 1. Subtract 2. I get x is less than negative 5. Okay, so this is a, you always look here. So we're going to ignore this top. We're only looking where our absolute values bars are by themselves. So this is a gray tor situation, because we flipped our symbol. So we're looking at where our absolute value bars are by itself. So I know I have a negative 5 and a positive 1, and it says x is greater than 1, parentheses, greater goes to the right, x is less than negative 5, parentheses, less goes to the left, and there is my graph. Okay. And my inequality, I'm going to kind of shove over here. Okay, it goes negative infinity to negative 5 with a parentheses, or 1 to positive infinity. There we go. Okay, so I want you to realize you're not looking until your absolute value is by itself. Okay? So let's look at number 16. No absolute values here, so we're not going to separate. We're just solving the two inequalities we already have. Okay, so we're going to do minus 7. I get 2x is less than negative 8. Okay, divide by 2. I get x is less than negative 4. Okay, minus 13. Negative 5x is less than or equal to negative 10. Divide by negative 5, and I get x. I flip my symbol because I divided by negative. 2 negatives makes a positive, so positive 2. So I have negative 4. Remember, smallest number, then bigger number. So this is an OR situation. So x is greater than or equal to 2, and x is less than 4. So this goes negative infinity to negative 4, or 2 to infinity. Now I want you to realize this symbol's that, this symbol's that. Infinity always has a parentheses. That kind of looks like I extended my lines. I didn't extend my line. I'm just saying that symbol goes with that symbol goes with that. Okay. Let's look at number 19. So again, this is kind of the same concept, except now it's and. Okay, so I'm going to solve. So I'm going to subtract 5, I get negative 4x is less than or equal to negative 12. Divide by negative 4, so I'm going to flip my symbol. 3. Okay, add 19, add 19. Get 2x is less than 19, 14. Divide by 2, divide by 2. X is less than 7. Okay, so I'm going to draw my graph. Okay, this is and, so it has to satisfy both. So I have my smaller number is 3, my bigger number is 7. Okay, x is greater than or equal to, or greater goes to the right, and it's going to be a square bracket. X is less than 7, so parentheses, goes that way. Okay, so it's double, remember technically they keep going, but we're only looking for where it's double shaded, which is in between. So we have 3, 7, just like that. Okay, let's look at number 20. This is an equal sign. Okay, therefore I'm going to rewrite exact. I'm going to go ahead and flip mine. So 4 minus x over 5 equals 5. And I'm going to get 4 minus x over 5 equals negative 5. And now I can solve. So I'm going to do minus 4 minus 4. Okay, sorry about that. Okay, so we get negative x over 5 equals 1. Now, I want to get rid of this 5, so how do you get rid of it? Well, that's dividing by 5, so we're going to multiply by 5, multiply by 5, and I still have this negative x equals 5. Divide by negative 1, divide by negative 1. I get x equals negative 5. Now, technically, I could have multiplied both sides by negative 5, and that would have canceled the negative, so either way. Whatever you think of. So I'll show you that on this one. So minus 4, I get negative x over 5 equals negative 9. Now remember, a negative times a negative is a positive. So if I do times negative 5 times negative 5, this negative cancels this negative, and the 5 cancels the 5. And I get x equals, well, negative 9 times 5 is positive 45. So my solution, least to greatest, would be negative 5, 45. Okay, so let's look at number 23 and 24, and then I'm done. So 23, my absolute value bars are alone on the left side of the inequality, so I can go ahead and separate 3 over x over 9, 3 minus x over 9, sorry, is greater than 2. 3 minus x over 9 is less than negative 2. So this is kind of the same concept. I'm going to show you another way to solve these, just so you can kind of see. It's very similar. This one just has an inequality, just like number 24. It's very, very similar. So on this one, if I want to get rid of my fraction before I start, I could multiply everything by 9. Well, this 9 and this 9 cancel. 3 times 9 is 27. So I just have minus x is greater than 18. Okay, so then I can do minus 27. Oh, 27. Minus 27. I'm getting a calculator out for this one. So 18 minus 27 is negative 9. So I get negative x is greater than negative 9. Well, I need to divide by negative 1. And that cancels, and I flip my symbol, so I get positive 9. So again, I can do the same thing. Times 9, times 9, times 9. This cancels this, and I get 27 minus x is less than negative 18. So minus 27 minus 27. I get negative x is less than negative 45. Divide by negative 1, divide by negative 1, flip my symbol, positive 45. Okay, so I'm going to use the space down here. I have 9 and 45. X is less than 9. X is greater than 45. So these are parentheses, and there's my answer. So negative infinity, because this is greater to 9, or 45 to infinity. One more. You don't have to graph this one. Okay. So looking at number 24, my absolute value bars are alone. It's equal, so I'm going to rewrite negative x over 5 plus 3 equals 8. Negative x over 5 plus 3 equals negative 8. And I'm going to solve. So minus 3 minus 3, negative x over 5 equals 5, times, so I'm going to multiply by 5, get negative x equals 25, divide by negative 1, divide by negative 1, x equals negative 25. Okay, minus 3 minus 3, negative x over 5 equals negative 11, times 5 times 5, negative x equals negative 55, divide by negative 1, divide by negative 1, x equals positive 55. So least to greatest, negative 25, comma 55. Alright, good luck on your test. If you have questions on any of the other problems, feel free to let me know. Have a good night. Oops, sorry you can't even see that. There's one view at that first.